IP with video 2 on transmission line and antenna theory. If you haven't seen it, see the video on transmission line and antenna theory before watching this one. These are the views from the first video showing the progression from discrete components R, L, and C in discrete circuits with currents and voltages, progressing into the integration of that kind of system into a transmission line where there are no voltages or currents needed to transfer energy. This video is a counterpart to that, showing why these theories do not apply to antennas. Antennas are not tuned circuits, they're not resonant, they don't carry currents, there's no sign distribution of current or voltage on the antenna. All that is false. It's a result of a gross oversimplification by incorrectly applying discrete circuit theory to antennas, which are actually transmission lines. Upper left, and by the way, this is not a trivial study on my part. I've been spending much of 5 years studying from 1917 onward in the old Institute of Radio Engineers and IEEE archives and all the high-level sources I can find. And all the antenna theory I can find based on circuits is incoherent. It makes no sense. This is the only explanation that does make sense. And it should be obvious that a transmission line works in a transmission mode, not a current flow mode, because that's what it's called. The starting place for this is the false assumption that transmission lines and antennas are electrical circuits. The first thing we learn in electricity is that the work in a circuit is done by electrons, which bear a charge, and the law that all circuits must be a closed path. Open circuits do not convey current and do not do work, period. There's a dipole. See the arms? There's no circuit there. That is not an electrical device, not a current carrying device. Therefore, the usual representation of this kind of distribution of voltages and currents on a dipole is complete fabrication and absolutely false, because it is impossible, if these dipole arms are part of a series circuit, for the current distribution in a place on the line to be different from any other place, because the current flow in a series circuit is everywhere the same. So throw this out. It's worthless. And listening to 7005 for DX this morning. Conditions stink. I don't think there'll be any. This kind of distribution is impossible in a series circuit of current versus time, because current is always the same everywhere. If it isn't, electrons are magically being added or falling off the wire. So all antenna theory of alternating time variable voltages and currents is wrong. Again, it's a result of a horrifying oversimplification, and attempting to apply discrete circuit theory to something that is not a circuit. Basically, what an antenna is a transducer. It's a transformer. It transforms, let's say, a 50 ohm input impedance from some circuit or transmission line to the free space, what is called resistance of 376 ohms. There's a document out there that shows how this figure was evolved. It's kind of messy. It uses 3D surface models of free space and adding up increments of incremental resistance into that 376 figure. But notice there are no two terminals here. Back here in network theory, input port, 2 terminals. Output port, 2 terminals. Currents in each one, voltages across each one. Not here. Ain't happening. What's happening is that antennas are electromagnetic devices. They carry fields, not voltages and currents necessarily. And again, if they're open circuit, like a dipole, there is no current flow in that because the ends aren't tied together. A loop may be a different story. Fundamentally, our method of analyzing an antenna from Maxwell on the 1800s is to take an assumption of a feed point condition, power, voltage, and current, which is automatically erroneous because that depends on the antenna's resistance or impedance, and that's an unknown. So the input is just assumed. But in the form of, as in discrete circuits, R plus or minus JX, where R is resistance, plus or minus refers to the sign of the reactance, either plus is inductive, minus is capacitive. J indicates a J operator that it's possible for this term to go into an imaginary region, and that would be anything but the first quadrant on a graph, where R exists on the x-axis. That can be equated to magnitude impedance, which is the Pythagorean sum of the resistance squared plus the reactance squared, and the square root of that. That's just the formula for calculating the hypotenuse of a triangle. Very, very simple math. Series LC circuit, parallel LC circuit with a resistance. That's all in circuits. This is universally how antenna feed points are analyzed. If you buy an antenna analyzer, a VNA, impedance analyzer, whatever, it's going to give you a result for an antenna in this form. It's wrong. And the first proof that it's wrong is that, in this system, if it's a 50 ohm, as we say, resistive input to the antenna, going to 376 ohms free space resistance, what does resistance do with energy? It turns it into heat, a little bit of light, maybe a little bit of microwave emission, but resistance destroys energy. If this system were resistive, nobody would hear our signals because the energy from the antenna would be dissipated as heat. The input to an antenna is not resistance. Resistive is a poor term, but I use it. But what's happening here is not resistance, but a forward transfer of energy into free space. And realize this can't be resistance also if the conditions necessary for efficient energy transfer for the transmission line to also be 50 ohms, because the simplified equation for transmission line resistance is square root of L over C. There's no R in that formula. Therefore, there is no resistance. What this 50 ohms so-called resistive is looking through a forward transform into free space. That's a measure of energy propagation, not of resistance. Similarly, the idea of X is fabricated from discrete circuits. It's false, but it's about the best thing we have to describe it, because understanding antennas requires math that is far more complex than this. And that takes us back to Maxwell's three-dimensional field equations. We can't wrap our minds around that on a daily basis, so we default to this horrible oversimplification. Where this X term comes from is, and I forgot to write this down, so let me write it down. X comes from this relationship. Arc tan X over R. It's a power factor formula used in electrical power, used in circuits to find phase angle. When there is a reflection from the antenna because of a mismatch, that's not necessarily because there's reactance. It's because there's a reflection, there's a lack of energy transfer, and there's a phase shift. And that's where the X term in antennas comes from. Yes, the length of an arm in a dipole can be reckoned as a inductor with no turns. Yes, there's a M field between the arms, a mutual field, but that ain't an inductor because it's an open circuit. So we got to throw these discrete circuit concepts out and try to wrap our minds around electrostatic and magnetic fields. And that, again, is not easy. But when we see an antenna analyzer plot, realize that two things. Number one, that ain't resistance. And number two, according to my favorite book, Radio Antenna Engineering, any residual reactance indicates an inefficiency in the antenna. And that residual reactance here is the source and the cause of reflected power, which not only reduces the energy emitted from the antenna through the antenna's directionality, and there's no such thing as antenna gain. Nothing in this universe has gain. There are videos that say that a low SWR or 1-to-1 indicates a perfect match in efficient antenna operation. That's false, because a perfect match can be indicated by magnitude Z being 50, which is 50, but there still may be residual reactance included in that mag Z, which is the second term in R plus or minus JX, and that is not an efficient antenna. And I don't care what stand's made up, it's wrong. Yes, that's the oversimplified version that hams get. Get into the commercial broadcast world, you'll find out what's so grossly wrong with ham theories. Nobody gets an eye put out, but what they get are inefficient, poorly operating antennas, especially if they use some goofy form of off-center fed or end fed, which is just a waste of time, and they're not tuned correctly. And this is why too many operators have to run amplifiers on the air, because nobody can hear them with just the antenna, because their antennas don't work well. So those are the basics of antenna theory. And again, it's critical to understand that antennas are not electrical circuits, unless maybe they have a loop involved where current can flow through them. But generally, if they're fed by transmission lines, it's best to assume that the whole system is nothing but transmission lines. And there are models which reckon the arms of this dipole as each a transmission line of its own right. And for dipoles, that transmission line operates against the ground, the earth. And radio antenna engineering shows data on the so-called feed point resistance, which again isn't as a function of height above the earth for a dipole, showing that ideally an antenna half-wave elevated, a dipole, is 50 ohms. And that feed point so-called resistance goes up as the antenna is raised. So there goes the myth of the higher the antenna, the better. Not with a dipole. You put that dipole at 60 or 80 feet, it may be 100 ohms, and you'll play you-know-what trying to get it matched. So there is video 2 on antenna theory.